By way of introduction, my name is Bill Tanzola. I'm a principal director within Accenture's technology practice. Would say I spend the vast majority of my time helping our clients with their most challenging technology issues, which these days entail how do we make a rational business case to move our compute and networking and storage capabilities to the cloud. But I also serve in a secondary capacity. I serve as the communications and media liaison to our quantum computing organization. In this role, I help understand the implications of how quantum technologies are going to be affecting the day-to-day activities of our clients. As with many things, Accenture focuses on the demand side. So what are the business challenges that this technology can possibly help us so we look at value realization, and when it comes to finding things, how do you industrialize delivery? A lot of this stuff now is based on activities that are done in the lab or done in Jupyter notebooks, but don't really address the modern IT requirements of our clients. And therefore, we specialize in helping bridge that gap between the two. Our program has been going on for about 6 years now, and it focused on quantum computing, as that was one of the first areas out of the gate with that approached capabilities that our clients could potentially take advantage of. We focus in 3 areas here: optimization, machine learning, and sampling and simulation. From my perspective, most of the work originally was in optimization, but then has switched over to machine learning as those capabilities have matured, both from a hardware perspective and a software perspective. More recently, we've looked at quantum networking. This technology is slowly coming out of the labs, off the tabletops, and are being deployed in test beds in order to try this out. This leads to the possibility of our clients asking us, why is this important to us? And we'll get into that shortly, but it is an area that we're looking at, and we focus again on 3 areas here: network simulation and emulation, because let's face it, a lot of the networks don't exist except for in theoretical models. Test beds, to the extent that the technology can be brought out and used to prove out business scenarios. We'll try that. And then I can't not discuss quantum key distribution. It is one of the first commercial technologies. It's following a different path in terms of how the networking aspects take place, but it is there nonetheless. And then finally, we look at this in terms of post-quantum cryptography. We refer this to as crypto agility. So as the industry matures, we definitely take the approach of zero trust security. So verify everything. Do not put all your eggs in one basket. And as a result, looking at quantum computing, quantum networking as a means of securing things should be done within a much larger context with overlapping layers of checks and balances. Now, we recently last year published a paper, and don't worry, I'm going to highlight this so you don't have to squint your eyes and look at it, on where the state of quantum networking is. I was one of the lead researchers on this, and we partnered with a company called Aliro Quantum on it. And it looked at really 3 areas where potentially we could add value, or companies could add value. Needless to say, secure communications was one of the key areas. How can the various attack vectors be mitigated by using distributed entanglement in order to secure to send data, or not send data, teleport data from one area to the other. The second thing that Mark also mentioned is quantum sensing, which is the first use case that attempts to keep all data quantum, and then finally distributed quantum computing. Now, most of these are still very theoretical, which means that from where the people should think about how to do it is, 1, learn as much as you can. I have a POV that, the link is on the previous slide. There are test beds out there. Participate in the design and the development and watch their enhancements. and exploits that they occur. And finally, or look at QKD. If you're interested in that technology, then it's a good way of getting your feet wet and seeing if it is. Most people say, why should I worry about key distribution in general? Once you overcome that, you can then look at, is quantum computing or quantum key distribution a means of getting you to a more secure position compared to where you'd like to be? And then finally, embrace crypto agility. Attack vectors change every single day, and the prospects of quantum computing breaking things is a scary prospect. There are ways around it, and it should be looked at within a holistic manner.